So we talked about adding, subtracting, and scalar multiplying to matrices. Now we want to look at actually multiplying to matrices when possible. So here's kind of the abbreviated form of the process. The book goes through in gory detail with a lot of technical notation on how to do this. Okay, so there's really only two steps, but the second step is a doozy. Okay, so be careful. First, we want to determine the order of the two matrices you wish to multiply. Okay, so A and B, if I think about this, A is a 2 by 2 matrix, and B is a 2 by 3. Okay, and now what I need to have happen is that the rows, or the columns from the first matrix, that's the second two, and the rows of the second matrix, those must be the same. Okay, so they have to be the same. If they're not, you can't do the multiplication. Okay, and then just a side note, the final matrix is going to be a 2-row by 3-column matrix. Okay, so that's where the other numbers are useful. Okay, all right, so now we're going to get started. It says to obtain a certain entry. Okay, so let's just say start out with finding the entry in the upper left. Okay, it says take the row of the first matrix, so it would be this row, and I need to multiply that by the entries in the second column and then add those products. Okay, so just to be clear, this first column, it would be 2 times 3 plus -5 times 6. Okay, then, okay, so that's the upper left column. Now I repeat that process, kind of going through all the columns. So it'd be row times second column, and that would go in this entry. So this is A12, so first row, second column. Okay, and so again here, this would just be 10 plus 0. Okay, next one, I now do row 1, column 3. So 2 times 4 plus -5 times -8. Okay, and so then we can continue in that way for here. So we'd have, I'm going to erase all the highlighting. So we'd have 3 times 1 plus 0, and then it's kind of nice because all the other elements are going to have 0 in the second one. So it'd be 5 plus 0, and then 4 plus 0. Okay, and that would be this matrix product AB. Okay, and then now just simplifying, we would get, let's see, 6 plus -30 is -24, and then we get 10, and then 8 plus 40 is 48, and then we get 3, 5, and 4. Okay, so for some of you, you don't need to do this intermediate step. You can jump right to the end, and that's perfectly fine. Okay, so moving on, we found AB. Okay, my work is going to be a little off-center because I took up more room on AB than I anticipated. So BC, okay, so now this is a 3 by 2, right? Or 2 by 3, I'm sorry. Try that again. This is a 2 by 3, and C is a 3 by 1. So if I look at the columns of the first and the rows of the second, they match, so it can go on. I can do the matrix multiplication, and the result is going to be a 2 by 1. So then when I do BC, I'm going to say, okay, well, I'm going to take row times column, and when I do that, I end up getting 3 plus 0 plus 24 or 27 in there, and then now I don't have any more columns to go through, so I have to switch the row. So switch the row, and when I do that, I get 6 plus 0 plus -48, so I get -42. Okay, And so that's matrix product BC. Okay, now next one, CB. Okay, C, now the order again matters, so we do 3 by 1, and then we have a 2 by 3. Is that possible? Nope. Okay, because they're not the same, so I'm just going to say not possible. Okay, so we've kind of set up the story here. If you want to take your time and show more work, you certainly can. Otherwise, you can jump kind of straight ahead like I did for BC. I want you to try BD and DB, and when you have the answers, resume the video. So here are my answers. Double check them. I did these all in mental math. I did check them twice, so they did work out, but I could have made an error. Okay, so yeah, but both of these are possible. You just get different matrices, and in particular, what I wanted to illustrate with this, that BD and DB, matrix multiplication is not commutative. Okay, so that's actually one big product or result that we get, is that matrix multiplication is not commutative. It is associative, meaning that if you have like 3 matrices A, B, C, and you happen to want to multiply the first or the last two first, that's the same as if you were to do A, B first and then multiply by C. That is okay. We're also assuming that, you can multiply all this, blah, 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 but there we go. So that is fine. When we have distribution, we have to be careful about which side we apply it to. So for example, and this extends from the non-commutativity property. So if you have A and then B plus C, you can say that's the same as A, B plus A, C, but you cannot say that that's the same as BA plus CA. Okay, so there's that. So that's left distributive. Right distributive would just mean like you have A plus B all times C, and then in this case you would have the matrix product as AC plus BC. Okay, noticing that the C goes on the left, so this is kind of the one that takes a little bit more mental energy to think about. But you do have to be careful about the order of multiplication, because matrix multiplication is not commutative, meaning that AB is not equal to BA. Okay, as we found out above with BD and DB. All right, so matrix multiplication, big idea. Make sure that the orders make matrix multiplication possible, and then it's row of first times column of second, adding the products as you go.